Hello everyone. Welcome to this video on learning mathematics through concepts and examples. Today, we are going to solve some example problems from definite integrals. Let's get started. Okay, here I have two problems. Evaluate the following definite integrals using fundamental theorem of calculus. So the first one is integration from 0 through 1 of this function x squared plus 3 times e to the power x with respect to x. So in order to integrate this 0 through 1, x squared plus 3 times e to the power x dx, this is equal to, so in order to integrate x squared, we use the power rule. That means we increase the power by 1 and divide by the new power. So that will be x cubed over 3 plus, to integrate the second one, e to the power x is multiplied by 3. So 3 is a constant multiple, so we keep as it is. And integration of e raised to x is e raised to x because the derivative of e to the power x is e to the power x. So the integration will also be the same. And we have to evaluate this between 0 and 1 using the fundamental theorem of calculus, meaning we plug in the upper limit into this, subtract, and then plug in the lower limit. So if I plug in upper limit 1, it will be 1 cubed over 3, which is 1/3, plus 3 times e to the 1. E to the 1 is e, so 3e. We subtract and plug in the lower limit. If you plug in 0, 0 cubed over 3, that's a 0. Then plus 3 times e to the 0. E to the 0 is 1, so 3 times 1 is 3. So we get 1/3 plus 3e minus 0 plus 3 is 3. So we are subtracting a 3. So there is a 3e, and then we have 1/3 minus 3, which is negative 8/3. So that is the value of the definite integral. So here we use the reverse process of differentiation to find the integration. Okay, let's move on to next one. So here in the second one, we have to integrate from 1 up to 2 of the function 1 over x with respect to x. Now you know that the derivative of logarithmic function, derivative of natural log x is 1 over x. So integration of 1 over x will be natural log x. Natural log x. The value of x are between 1 and 2. They are already positive. So I don't need to take the absolute value there. Otherwise, I need log of the absolute value of x. But here we don't need that. Now we have to evaluate this between 1 and 2. Between 1 and 2 using the fundamental theorem of calculus, meaning we plug in the upper limit there, we subtract, and then plug in the lower limit. So if you plug in upper limit, natural log 2, subtract, and then plug in lower limit, natural log 1. Log 1 is 0, so natural log 2 minus 0. Natural log 2 minus 0, which is equal to natural log 2. So that is the value of this definite integral. Okay, so in both of these, we use the reverse process of differentiation to find the definite integral. Okay, now comes the next set of problem here. So if we look at the first one, we have integration from 0 up to pi over 2 of cosine x with respect to x. We know that the derivative of sine x is cosine x. So integration of cosine x will be sine x if you use the reverse process. So sine x, and we have to evaluate this between 0 and pi over 2 using the fundamental theorem of calculus. So what do? We plug in the upper limit, subtract, and plug in lower limit. So that will be sine upper limit means pi over 2 minus sine lower limit is 0. So that will be sine pi over 2 is 1 and sine 0 is 0. So 1 minus 0 is equal to 1. So the value of that definite integral is 1. Okay, so in these three examples, first, second, and third, we were able to use the reverse process of differentiation to find the value of the integral. Now let's look at this one. So in this, we have 0 up to 1 of the square root of 2x plus 1. Or I can also write 2x plus 1 with power half square root. We integrate with respect to x. So if you look carefully, we are integrating a composite function. Your outside function is a square root function, and inside function is a linear function. So if you are integrating a linear function, okay, composite function with the inside function, linear function, then you can use the reverse chain rule, meaning you evaluate the integral, keeping the base, okay, using the power rule because there is a power there. So that will be equal to 2x plus 1. So if you use the power rule, you increase the power by 1. So half plus 1 will be 3 over 2. Divide by the new power, which is same as dividing by 3 over 2, right? Which is same as multiplying by 2/3. And then we are using the reverse chain rule, meaning we divide this quantity by the derivative of this inside function. Derivative of inside function is 2. So you divide that by 2. And then you evaluate between 0 and 1. So what happened here is 2 and 2 get cancelled. Now if you plug in upper limit, you have 1/3. So if you plug in 1, you get 2 times 1, 2, plus 1 is 3 raised to 3/2. So that becomes 3 raised to 3/2. And then minus, we plug in the lower limit now, 1/3. This 1/3, if you plug in 0, 2 times 0 is 0, 0 plus 1 is 1, 1 raised to 3/2. 1 raised to 3/2. So this one, if you look at the first, it is like 3 cubed. 3 cubed is 27 with the square root. Power half means square root. So that's like square root of 27 over 3 minus 1/3. So we have a common denominator of 3. So I can write my final answer here. Common denominator 3, which is already there. Square root of 27 is 3 root 3. And then we have minus 1. So that is the value of the definite integral. Remember the technique. In this one, we have a composite function with the inside function linear. So if you have a composite function with inside function linear, we can use the reverse chain rule to evaluate the integral. That's what we did here. Okay, let's move on to next set. Here I have 2 questions. If you look at the first one, we have integration from 0 up to pi over 2 of, okay, let me write this one a little differently. I want to pull this 2 out. I'll write that constant outside. Then you have e to the power of sine theta. Okay, I wrote this one, e to the power of sine theta. Then 2 is already pulled out. I'm left with cosine theta d theta. I'm going to write that here. Cosine theta d theta. Now, if you look at this carefully, this part is a composite function, e to the sine theta. That's a composite function. Your inside function is sine theta. And notice that the derivative of inside function is also here. Derivative of sine theta is cosine theta. So if the derivative of inside of the composite function is also there in the integral, we can use the u substitution. Okay, we can use the u substitution where u is that inside function. So let u equal to sine theta. Then what happened is du, if you find the derivative, is equal to cosine theta d theta. So if we do that, let's see what happened. 2, I'll take care of the limit in a second. So e to the sine theta is u. So that will be e raised to u. And then cosine theta d theta is du. Okay, remember one thing here. These values, 0 up to pi over 2, these are the values of theta because we are integrating with respect to theta. But now we are integrating with respect to u, so we need the values of u. And to find the value of u, we have the equation here, u equal to sine theta. So if you plug in theta equal to 0, the lower limit, u is equal to sine 0, which is 0. And to find the upper limit here, you plug in theta equal to pi over 2. So u will be equal to sine pi over 2, which is 1. Which is 1. So we can integrate this easily, which is equal to 2 integration of e to the u with respect to u is e to the u. We have to evaluate between 0, 1, and 1 using the fundamental theorem of calculus. That is, you plug in the upper limit, subtract and plug in lower limit. So if you plug in upper limit, it will be 2e, because u is 1, e to the 1 is e. And then minus, if you plug in 0, e to the 0 is 1 times 2 is 2. So the value of the integral will be 2e minus 2. And remember, in this one, we use u substitution to solve it. Always remember the technique. We use u substitution because we have a composite function here, which is e raised to sine theta, and the derivative of that inside function is also there. So if the derivative of the inside function is also there, we can use the u substitution. And in order to make that happen, what we did is we basically moved this 2 outside. When we move that 2 outside, it fits the condition for the u substitution, and we use it. Okay, now let's look at this one. So here we have 0 up to pi over 4. 0 up to pi over 4. We have sine theta over cosine theta raised to 4 d theta. You can clearly see that denominator is a composite function, cosine to the power of 4. Inside function is cosine. And if you think of the derivative of the inside function, derivative of cosine is a negative sign, but there is only sine. We can adjust it. We were looking for negative sign, which was not there. So what I can do is I can multiply inside by negative and also outside by negative, because negative and negative makes things positive and nothing changes. So by doing that, we can use the u substitution. U equal to inside of the composite function. So u equal to cosine theta. So we can write here, let u equal to cosine theta. So this implies du equal to negative sine theta d theta. So that means this will be equal to negative 0 up to pi over 4. So we have u to the 4 in the denominator, because if we make the substitution, that will be u to the 4. But u to the 4 in the denominator is same as u to the negative 4. And then in the numerator, I have negative sine theta d theta. And you know that negative sine theta d theta is du. That is du. Now we can easily integrate this. So if you integrate this, let me write this side. If you integrate, what you get is you increase the power by 1. Okay, you increase the power by 1, meaning of that is negative 4 plus 1, that will be equal to negative 3. That will be u to the negative 3. And you divide by the new power. Your new power is negative 3. Negative 3. And you already have a negative sign outside. You already have that negative sign outside. This negative sign is there. And we have to evaluate this. But remember, I forgot to change the limit of integration. Let's do that. We cannot have 0 up to pi over 4 here, because we are integrating with respect to u. So let me fix that. So what I mean by that is, here we have theta equal to 0, right? Because here we are integrating with respect to theta. Theta equal to 0. When theta equal to 0, u will be equal to cosine 0. Cosine 0 is 1. So the lower limit happens to be 1. And upper limit, we have pi over 4. So if theta is pi over 4, u will be equal to cosine pi over 4. And cosine pi over 4 is the square root of 2 over 2. Or we can also write 1 over the square root of 2, which is the same thing. 1 over square root of 2. So that means we have to evaluate this between 1 and 1 over square root of 2. Now let's see. I'll write here one more time just to make it a little simple. So negative and negative, that makes positive 1 over 3 in the denominator. And if you move that u cubed, u to the negative 3 to the denominator, u to the third, evaluated between 1 and 1 over square root of 2. So if you plug in upper limit here, it will be 1 over 3 times 1 over square root of 2 cubed. And then minus, if you plug in the next one, the lower value, 1 over 3, 1 cubed. Now the first one will be, if I cube this one, it will be 1 over square root of 2 cubed, which will be 2 root 2. Okay, which will be 2 root 2. And we can write that in the numerator because it is 1 over, right? Whatever you do with this one, that goes to the denominator. It's the reciprocal of reciprocal, so it goes in the numerator, I mean. So that will be 2 root 2. 2 root 2. And then what we are left with, the denominator is 1 cubed times 3, that's a 3. And here also we have 3, that means we have a common denominator of 3. So minus 1 over 3. So that is the answer. So try to be a little bit careful when you do that simplification. Other than that, this is not that difficult. We also use U substitution here because if we multiply inside and outside by negative sign, we see that the derivative of the inside of the composite function is also there. So we use the U substitution. And always remember, U is the inside of the composite function. Okay, we are going to do one more example in this video. So here is our last example. So we have to evaluate the definite integral. I don't know why I wrote indefinite. Definite integral. These are all definite integral. So evaluate the definite integral 1 up to e of this one. So you can see that if I want to rewrite this, I can write like this. I can write it as 1 up to e. We have natural log x. 1 over x is in the denominator, then dx. So if I write like this, what I see is something interesting. We have natural log x, and the derivative of natural log x is 1 over x, which is also there. That means if the derivative of the function is also there, we can use the u substitution. So u equal to natural log x. So let u equal to natural log x. So du will be equal to 1 over x times dx. So we can easily make that substitution. So this will be equal to, so this is our u, and then 1 over x times dx is du. We need to write the limit of integration. So these are the values of x. So when x equal to 1, u will be equal to log 1 or 0. And when u equal to e, I mean x equal to e, u is equal to natural log e, which is 1. So we are basically integrating from 0 up to 1 of this function. So we can use the power rule to integrate this. So power of u is 1. What you do is when you integrate, you increase the power by 1. So it will be 2 and divide by the new power, evaluated between 0 and 1. So if you plug in upper limit, 1 squared over 2 is a half. Then minus, plug in the lower limit, 0 squared over 2 is a 0. And half minus 0 is half. So that is the value of the definite integral. So here also, we use the u substitution. So we have seen like 3 important techniques to solve the definite integral in this video. The first technique was the reverse process of differentiation. The second one was if there is a composite function with the inside function linear, what you do is we evaluate the integral, and then at the end, we use the reverse chain rule, meaning we divide by the derivative of inside function. And the third type of example we did involved the composite function, or you can say that if the derivative of function is also there in the integral, we use the u substitution. Okay, so that's all in this video. I hope you find this video helpful. Thank you so much for watching.